Welcome, everybody, to the October 2025 meeting of the Central Florida Astronomical Society. I am your host, Frank Kane, and your president for the next 1 hour, because after our main speakers, we're going to be holding our elections for the 2026 Board of Directors. So do stick around. We do need a quorum for that, so please stay around after our main speakers, who I will introduce shortly. If you are watching this and you're not yet a member of the Central Florida Astronomical Society, what are you waiting for? There are many benefits to joining, including access to our private events. You'll hear more about that later in the club news, and our dark sky viewing locations, such as at Geneva, Florida. We also have our Lunar telescope program and remote observing program as well. If you have too many clouds in Florida, we have a site in Texas you can access as well. Contact loners at cfas.org if you want to learn more about that. We also have a vibrant online community at cfas.groups.io where we all talk shop about astronomy stuff. And we have quarterly meetings at the Seminole State Planetarium, which is about the best venue you can imagine for a bunch of astronomy nerds. Your membership also includes the Astronomical League and its Reflector Quarterly magazine and all the benefits therein. And you can feel good about joining because we're a nonprofit 501c3 organization, 100% volunteer powered. Every penny of your dues goes toward our mission. You also get discounts on Astronomy and Sky and Telescope magazine for joining. And also, you have the ability to do live Q&A with our guests because you get the invite to the actual original meetings that you're watching right now. If you want to learn more, head over to cfas.org and learn more about our membership plans, which range from $15 to $50, whatever you got. Tonight, we've got some really cool speakers. We're going to be joining with Manny Pimenta and Phillipe van Nedervelde of the Virtual Moon Project. I'll introduce them shortly. Following that, we'll have our officer elections for 2026, and we'll have our usual club news. There's a lot going on, so do stick around for more on that. And as always, we'll wrap up with our member astrophotography and sketching showcase. We got some awesome images to share with you tonight. And let me introduce our main speakers, and we'll dive right in after that. And some quick housekeeping. If you're not on mute, please mute yourself and stay muted throughout the presentation. I forgot to put on the little switch in Zoom that automatically mutes you when you're joined. So do please keep yourself sanitary there with the mute. If you have questions for our speakers tonight, please drop them in the chat, and we'll get to as many questions as we can after the presentation. With that, let me introduce our speakers. Joining us tonight is Manuel Manny Pimenta. He's an electrical engineer with a master's in computer science, a 25-year space advocate focused on establishing a permanent human presence on the moon. He served as a VP of the New York City chapter of the National Space Society, founding board member of the International Lunar Observatory Association, the Return to Moon project director for the Space Frontier Foundation, organizer of 2 Return to the Moon conferences, founder of Lunar Explorer, created the world's first fully immersive VR simulation of the moon over 20 years ago. Yes, folks, VR has been around for a while. And more recently, founder of Virtual Moon LLC, which we're going to hear about tonight. Also joining us tonight is Phillipe van Nedervelde, a futurist and transhumanist writer, activist, and speaker. He advocates for space settlements to avoid human extinction. He's also an early developer in virtual reality. And whoever's not on mute, please mute yourself. And in 3D Graphic Studios eSpaces, patent filing inventor of See-Through, applying VR to security systems, and co-CEO of X3D Technologies. I've heard of that one. A virtual worlds production company, co-founded and co-owned by Hollywood movie director Michael Bay. Van Nedervelde directed eSpace's production of 12 online 3D training simulators for British Petroleum and the broader oil and gas industry to certify well lease operators in the maintenance and troubleshooting of oil and gas well surface equipment. He's also developed virtual reality projects for the Munich Airport Center, Simsala Grim, Virtual Europe, and the transhumanist-themed sculpture in Martin Rothblatt's Terrasem Island. Van Nedervelde is also the executive director for Europe of the nanotechnology think tank, the Foresight Institute, from 1997 to 2014. He holds a position of global task force member for the Center of Responsible Nanotechnology. As executive director for Europe, Van Nedervelde interfaced with the media and represents the Institute at European Union events, including EU parliamentary hearings. He's spoken at various conferences, including a working group on unconventional security threats, organized by Washington, D.C.'s Strategic Assessment Groups of the U.S. Central Intelligence Agency's Directorate of Intelligence. Van Nedervelde co-authored the Foresight Guidelines on Molecular Nanotechnology, that's a mouthful, and was cited in Ray Kurzweil's book, The Singularity is Near. Van Nedervelde serves on the board of the directors of the Lifeboat Foundation, an organization dedicated to reducing existential threats in the world, and he serves as the international spokesperson for the foundation and represents the foundation by fundraising, giving multimedia presentations like tonight, and addressing the media. That has got to be one of the most amazing bios I've ever had the honor of reading. Thank you for joining us, Manny and Phillipe. I'm going to stop the share and hand it over to you.
All right, excellent. Thank you very much for the intros. I will start screen sharing and we'll get into our slide deck. All right, so let's get right into it. You've basically run through the main points of my introduction, so no need to rehash this. I just wanted to highlight a couple of things about some of these bullet items. So the one of them is the ILOA. I was a founding board member of the International Lunar Observatory Association, and ILOA just actually had a payload that landed on the moon earlier this year. And that was on the Intuitive Machines mission that landed on Malapert Mountain. And it was a telescope that was going to image the center of the Milky Way galaxy and beam those images live to Earth. Unfortunately, as you know, the Intuitive Machines mission helped me, whether it was giving me an instrument or giving the Intuitive Machines mission had a mishap on landing and tipped over. So that didn't work so well, but ILOA has an upcoming mission with another payload. So um, this has been an amazing adventure because I've had the opportunity to meet some of my moon heroes. I met Buzz Aldrin multiple times. I met Harrison Schmitt, Captain John Young, and this has been part of my involvement with the Space Frontier Foundation and running 2 Return to the Moon conferences. And one of the highlights of this adventure has been I had a chance to pilot the space shuttle simulator and do 3 landings. And this was at NASA Ames Vertical Motion Simulator, which is a very exclusive club. You can't actually pay to have this experience. I had some inside connections, and again, this was an amazing thing that happened out of the blue. One of my friends that works at NASA Ames arranged this for me as a surprise, and it was great. This is going back about 20 years or so. And this is where it all started for me. I was 10 years old. I saw these images live from the moon, beamed live. I used to live in Europe, so I actually stayed up late into the night with my dad and my uncle, and we didn't go to sleep until we saw the Buzz Aldrin and Neil Armstrong walking on the moon. And in a way, this also was the same starting point for Phillipe, but it was more on a subconscious level. And I'll let him tell you more about it.
So I won't add much to the intro that Frank already gave. So, but maybe the space specific part. Do we have that slide with me on my father's arm, Manny, in this
No,
deck?
I don't have it on this deck.
So, oh yeah, my father assured me many times that I was an eyewitness on television of the first step on the moon. And ever since, I've been a huge space buff. And I have, in my misspent youth, in my secondary education years, I founded the Belgian Space Information Center. I was born in Belgium, don't hold it against me. And so during my 6 years of secondary education, I built it out to the richest documentation center about space flight and a bit about astronomy in the Low Countries in Europe. And fast forward to the moment I met Manny, and I'd always wanted to do space-related virtual reality projects, and because that would unite my 2 great passions, intellectual passions, and Manny made that possible. So I'm eternally grateful to him for that and other things. And so out of that came the labor of love that we are presenting to you tonight, which is the Virtual Moon Project. For me, it is the marriage between virtual reality my bread and butter for over 35 years now. And my other passionate interest in the settling of outer space and going way beyond.
Okay, so thank you, Philip. So what is Virtual Moon? We are endeavoring to create the most accurate, realistic, detailed, and complete model of the moon ever made. We're using state-of-the-art VR technology. We're integrating the latest lunar data from all sources that we can access. And there's an interesting comment here, including real time. Once Virtual Moon is completed, we'll actually be able to take real-time video and still images from the moon and make it available to our users in virtual reality in real time as the images come through live. Virtual Moon is also a fun and exciting place to explore and hang out with your friends. It's going to be a sort of a social media environment, like next generation, avatar-based, multiplayer, permanent location, virtual location. And another way to think of Virtual Moon is this is a space-time portal, something similar to the Star Trek transporter, except the Star Trek transporter has a range of, I think, 10,000 kilometers or something like that. We can actually hit the moon at about 300,000 kilometers. So think if you had a transporter that you could travel to any point on the moon and land and walk around and see what's there and experience visually exactly what it's like to stand on the moon, that's the experience we're going for. Now, my first, this actually began as a personal quest. I've always wanted to experience what it's like to be on the moon. And as a naive 10-year-old, I thought that would have been possible by the year 2000. Well, it turned out in 2000 that there was no possibility. There was no way anybody was going to the moon, let alone myself. That's really what sparked my interest in getting involved in space advocacy at that point. I figured I needed to get involved and do something, no matter how insignificant or menial, because I hadn't done anything for the preceding period. So I might as well do something. And it's strange the way that the universe works. Sometimes you just have an intention, and then out of that intention, opportunities just open up. This, from a personal quest, it evolved into something that I'm passionate about sharing with the whole world. And it started crystallizing in my mind, why is this so important to me? Is that I really believe that to survive, we have to become a spacefaring civilization. Elon Musk is showing the way, but he really could use all the help that we can bring. And I think there are millions of talented and dedicated young minds out there that are needed. And our mission is to inspire those kids and ignite their imaginations and open up their minds to our future as a spacefaring civilization, an optimistic, bright future that will benefit everyone. And so one of the main tenets of Virtual Moon is once we, even the work that we've done now is accessible to everyone for free. And once we finish building out Virtual Moon in its complete form, we'll share it with the entire world for free as well. Now, besides the incredible luck of connecting with Philip and having him agree to join me in this project, again, one of those things about the universe aligning with your intentions, we've put together a really world-class team of advisors and team members that sort of give us a huge resource, a pool of resources that we can draw on to make sure that this project is the best that it can be. So I'm not going to go through the whole list, but you can see Dr. Jeff Hoffman is a retired NASA astronaut. He currently teaches at MIT. He was one of the team that repaired the Hubble Space Telescope on that first repair mission. The other name I wanted to draw your attention to is Andrew Chaikin. Andy Chaikin is the author of A Man on the Moon. His book was the basis for the HBO series From the Earth to the Moon. And another interesting team member that is very excited about our project is Dan Curry, who was in charge of all the special visual effects for the Star Trek series. And at the bottom, we're asking about you. Anybody on this call who want to join Virtual Moon and work with us and contribute or collaborate, we are open for business. I won't spend too much time on this because we really want to get to the demos as quickly as possible. But Lunar Explorer, which I'm very proud of, was the first and it's still the only fully immersive and interactive VR simulation of the moon. It was done in 2004. As a business model, it didn't really work because there was no consumer market in virtual reality 20 years ago. And that's the reason that we created a new company, Virtual Moon, because now the market is there. And so we are taking advantage of that. These are some screenshots from the original Lunar Explorer. We could orbit the moon at about 10,000 kilometers, or at low altitude, 100-kilometer orbits. We could land on any part of the surface of the moon and walk around. These are, one is the Apollo 15 landing site, the instruments on the surface. The top left picture is a Soviet sample return mission. We took Lunar Explorer to various conferences and events. On the top right is Robert Picardo from Star Trek. He's walking on the moon on Lunar Explorer. On the top right is Burt Rutan. He won the $10 million X Prize, and this was in San Diego about 3 weeks after the X Prize award. And there's Burt Rutan walking around on the moon. We had additional plans for Lunar Explorer. One of the things that we did is we built a lunar rover racing game, and we were almost done with development. We're 90% done with development, but we ran out of funds, and we never published the game. But this is the kind of experience we're also going to include in Virtual Moon when it's done, among many others. This is the Apollo 11 landing site. This is the best that we can do at the time, 20 years ago. This is a newer version. This is the Virtual Moon version, but even this is not in its final level of quality and visual detail and accuracy. So, Philip, if you'd go into data sources and the technology and so on, you have the floor. Philip, are you there?
I was muted and hunting for my audio. So I have a bunch of demos queued up for you, and you'll see demos in various stages of development. Some of them are finished, and others are still in development. But we've basically developed a set of demos which are kind of our advertisements or our ads to promote the Virtual Moon project and to show that we can do this stuff and give people a teasing taste of what the Virtual Moon project will become once we attract the sufficient amount of funds and when we execute the big vision that we have. So these demos are not the Virtual Moon projects. They are teasers upstream of the actual big Virtual Moon project itself, which is still in the future. Before I show you the demos, I want to tell you about one thing that the astronomers among you will probably find particularly interesting, which is one of the unique features of the virtual moon that we will develop, which is, to our knowledge, it will be the world's first and only for some time, highest resolution digital twin of the entire surface of the moon at such a high resolution that you can land your virtual viewpoint anywhere on the moon and have a view around you that is as detailed as the uh, Hasselblad photographs of the Apollo missions brought back to Earth. So how on earth can we do this? So this is a little bit of technical explanation of how we will achieve this. And if I'm talking Chinese and technical gobbledygook, do stop me and I will explain if needed. So we will be using a large amount of AI together with sparsity mathematics, which is the mathematics that teases out a rich signal from what seems a low information input. And so also lots of extrapolation, etc. So lots and lots of math. But here is the process that we will have. Right now, around the moon is orbiting the Lunar Reconnaissance orbiter. It takes elevation data of the surface of the moon and also photographic tiles of the surface of the moon. Now, the resolution of the LRO dataset, which is public domain, at its very best, which is in the polar regions, because that's where the non-circular orbit of the LRO probe comes closest to the lunar surface, the resolution there gets as high as, and that's the maximum, 10 meters per pixel. So 1 pixel of a polar terrain shot of LRO is equals to 10 meters square of terrain on the lunar surface. Now, obviously, if we land your virtual viewpoint and you look around, you're a virtual astronaut, you're going to see a big chessboard of 10 meters squares, right? So that's not interesting. What we are doing, and that's where I'm going to do some hand waving now, but we take that data set and together with still other data sets where the resolution is higher, as well as together with all of the surface photography that was done not only by the Apollo astronauts, but by unmanned probes. We use that all of that data to train a generative AI. And so that AI, we all know that AI is not perfect. It can hallucinate. It can make up things that aren't there. However, you can constrain the AI to generate within physically possible limits. So you can constrain it so that it doesn't do things which are just physically impossible. And one thing that I should mention before moving on is that in the data set, we will also include the existing maps, some of which are quite high resolution, of the makeup of the lunar terrain. So the lunar regolith is not uniform all over the moon. Some are lava fields and other places are mountains. So all of that data then is used to generate, this is generative AI, to generate a surface of the entire moon where each element, each tile of the terrain will be, we'll see how far we can go, how soon, but ultimately we want to have a resolution of 1 centimeter by 1 centimeter for the entire moon. And so we will go, in the case of the lunar poles, we would go from 10 meter square per pixel real world data, ground truth, to extrapolating and sparsity mathematics and AI and generative AI and all of that goodness, ending up with another thing we will use is something in AI called GANs. This is called a generative adversarial network. And that, why are we going to use that? Well, one way to optimize and to also do quality assurance on the output of the process is to give the AI a test image, which are, for example, the Hasselblad photographs taken on the Apollo missions. And you tell the AI, this photograph was taken at that location, the sun was at that position, so it knows illumination, and this is the resulting shot. Now you ask the virtual version of the moon to generate the shot of the lunar surface from exactly the same point of view, pointing in the same direction with the same position of the sun and Earth, etc. And so then the AI can compare the two results. And this is where the generative adversarial stuff comes in. Then the AI tweaks its model to keep on getting closer to the ground truth as shown in the Apollo images. And in the end, we end up with an image that is pixel accurate the same. So it's indistinguishable from the photograph taken by one of the astronauts. And then we know that we have tuned the virtual moon to perfection, or as good as we can get it with current means. And that means that when we go to a place on the moon, on the surface, where nobody has ever been, nobody has photographed it except from orbit around the moon, the likelihood that the scene that our virtual moon will show, that this scene will correspond to reality on the moon, is extremely high. It's not 100%. There's no such thing as perfection, but that is our ambition. And AI has advanced sufficiently to be able to do that. And so another important thing is that we will make all of that available, which is terabytes and terabytes of data, right, for the elevation and the terrain of the moon. We will make that available as a streaming virtual reality space that will be streamed to end users on their over the web. So it will be web delivered. And importantly, it will be accessible on any browser, on any device. What does that mean? You will be able to walk around the moon and fly around the moon and be inside of the virtual moon space on your smartphone, on your tablet, on your PC, your Mac, your VR headset, your AR glasses, and if you have a smart fridge and it has a web browser, you can see it on your fridge. So, or on your car, if your car central console has a web browser. So that's the omni device accessibility. And the final thing that I should mention before going to the demos is that the entire virtual moon will be all of what I just described, plus massively multi-user. which means that you don't have to go to the virtual moon alone and be alone in virtual space. You can go there with your friends, your family. You can hold meetings there. You can hold conferences there. You can shoot moon movies there, as a kind of a virtual movie location. You can do treasure hunts there with people. You can do multi-user racing games or treasure hunts, etc. So this is where you see that my background of doing multi-user virtual reality on the internet for 35 years comes together and fuses beautifully with my other interest in space flight. So,
All right, Philip, time is flying, and
oh, we don't
we
have
want
time for
to.
demos? Okay,
Yeah, we have time for demos, but
I'll go
so
faster.
this is one of the first images that Philip created for Virtual Moon. In the foreground is Malapert Mountain. Malapert Mountain is very significant in Virtual Moon. We may have time to talk more about that, but this is what a view from that location would look like. And so let's go to the moon.
I've
Philip,
I've queued the demos up.
okay.
Do we switch to my screen sharing, or do
Yes,
you want
yes,
to do it?
please.
Okay. So, how do I requested? Okay, that's great. And let me see. So here, yeah. Okay. Let's see. Um, I'll start with the movie, and here we go. Do you see my screen, gentlemen?
Yes.
Oh, we're
Okay.
seeing your desktop more specifically, but yeah, I think we're good.
Oh, now then I should change that. Let me see. Share. I wanted to do this. Do you see? Yes, that's
That's
better.
better. Yep.
Okay. So what you see on my screen here is, do you still see my screen?
Yes.
Okay, great. So the first demo was of the south pole of the moon. So we used LRO data and we converted it at a relatively low resolution, and we did the entire south pole. And here you see a video of that demo. I looked at having the demo live, which it usually is, but it's just not up for the minute. And so what you see here is that we have the all the major features of the South Pole, and then we inserted next to Shackleton crater a little future moon settlement. And in this south pole of the moon, remember, all of this is accessible via the web, and it runs in a web browser. Um, we can change the position of the sun. All of this is astronomically accurate in terms of the position of the sun and the moon. And so we can change the illumination of the terrain of the South Pole in real time. As you see, the very harsh light of the sun comes in at a very sharp angle on the poles. This is the South Pole, and so we also have. I'll see if I can fast forward, or if it shows this in this video. We also did an overlay of the water ice deposits on the South Pole, so that you can see where there are concentrations of possibly extractable water ice on the um, in the cold traps, etc., of the moon.
Now, as I said, we can provide links to all of these to anyone on this call. So you just reach out to us. We can send you the links.
Yes, let me move on to the next demo. Manny, you may need to bail me out because I may have inadvertently closed the browser with all the windows. Let me reshare. Yeah. So, okay. Little visit from Mr. Murphy. Where is my browser? So bear with me. Let me stop the share. Yeah. And find it here. Let's see. Yes, got it. All right. Now, let me show you one of the promotional demos that we made, which recreated in full virtual reality, including for your VR headset, if you have one, the landing of Apollo 11. I already entered the simulation and I closed the sound. But basically, what it does is you stand. This is an idea that came from Manny. The idea is you witness the landing of the Eagle of Apollo 11 while your viewpoint is standing on the moon. So you're kind of an eyewitness to a historical event. And here the lander is about to land. So I'm gonna browse backwards. So at the start of the experience, I'm putting on the sound. I don't know if you're hearing it.
No,
Okay.
we don't hear the sound.
Okay. That's okay. We'll do it without sound. But basically, we used the historical telemetry data to exactly determine all the movements of the lander. And so the experience begins with the lander being far away, a little bit to the left of the sun, and then it comes closer and it lands literally in front of your nose. I'll let it do that now.
And it's synchronized to the radio communications between the ship and the control center. So that's what the soundtrack is.
Exactly right. So I'll restart it to show you a different aspect of this same experience. So you can also, in your VR headset, experience it from a viewpoint that is floating around the lunar module.
It is now a clear-cut decision for immigration to make. There are really only two things.
Oh. Okay. So yes, so here we in your VR headset, you basically can go and sit literally on the porch at the top of the ladder of the lunar module, and you can have the best view in the house, better than Neil and Buzz had when they did the landing. And so and you can ride the lunar module all the way down to the lunar surface. And I'll do this hurried up. Notice how we correctly replicated the appearance of the shadow of the lunar module. This is exactly as it was. So we recreated here the next best thing to having been there at that time. It is the historically most accurate recreation, interactive virtual reality recreation of the famous landing on the moon. And so you can go and experience that in your browser and preferably in your headset at your leisure. Oops. And so I'll leave that one there and we'll go to another demo that we did. So here we are now at the Tranquility Base. as it is today. So Neil and Buzz have gone away, which you can see because the ascent stage of the lunar module is gone. And this is our recreation, again, as historically accurate as we know, of what the Tranquility Base location looks like today. Here too, we have the features that I mentioned earlier, which such as, hang on, I need to remove my interface for, yeah, that's it. So here I can call up the sun angle controller, and then you can see how now I'm taking some distance. So this is the entire location. And with the sun angle controller in real time, I can change the position of the sun along its arc. And that shows how the harsh light of the sun changes the aspect of the lunar surface depending on which angle you're using. So this scene is also entirely navigable. Let me show you another feature, which is, let me remove the sun angle, but highlight the astronauts' footprints. So we used the Hasselblad photographs, etc., of the Apollo mission, Apollo 11 mission, to position all of the footprints that we could find back, including this interesting set of footprints. So I don't know whether you guys know what this is, but this is the footprints of Neil Armstrong. He did this alone without Buzz. He went for a little walk all the way to Little West Crater, and then he stood here and he took a 360-degree panorama that you can find back elsewhere online. But after he took that little 360 panorama, he walked back, and that's the other set of footprints. He walked back to the lander and the center of the Tranquility Base. So I remind you that all of this is multi-user, so we can do screen sharing here. It really is a metaverse, and so here too, this is a demo of the also the future multi-user nature of Virtual Moon. The next demo is one where we are in an observation dome at the top of Malapert Mountain. So let me go here. The terrain, so this is a virtual reality space, but the terrain is actual lunar terrain. It's not fictional, it's not invented. It's your 360-degree view if you were to stand on top of Malapert Mountain, which is a mountain that I will be showing you in the next demo again. And so this is a demo space where we can where we plan to have a kind of a museum, but for the moment we have a number of globes that we can show to visitors and discuss with visitors, and so
and it's also a virtual meeting venue. You can hold meetings, and we have screen sharing there as well.
Correct. And this is a wireframe model, 3D, of the F1 engine that took the Saturn V from Florida to Earth orbit. Next one.
Hey, Philip, before we get into another demo, because we have a whole bunch more to show you, but we are 10 minutes from the hour, so maybe we take a break, see if people have questions and answer some questions, and then if there's more time at the end, we can continue and show you more demos.
Agreed. I will leave this on the screen. What you're seeing on the screen while Manny and I answer some questions is the Selene construction site. So Manny designed a moon city inside the top of Malapert Mountain. And so I can change the lighting again, etc. But this is the actual terrain using LRO data of Malapert Mountain right there under my cursor. And with that, I rest my case and ask any questions you like.
Awesome, folks. If you have any questions, drop them in the chat and I'll read them out. Or if you want to ask live, go ahead and hit the raise hand icon under the React section there, and we'll let you ask them live too, whatever you want. I'll kick it off, though. I am geeking out over this harder than you can imagine. So my first question is, what are you using for a terrain engine for this? Is this how are you like rendering this entire celestial body in real time and zooming in and zooming out so smoothly?
So the origin of the terrain imagery is a Lunar Reconnaissance orbiter. On the website, which we are looking at here, we are using a rendering engine called Babylon.js, which is open source, and it uses the WebXR web standard, which is together with WebGL, is basically how you can do very photorealistic and very detailed virtual worlds, single user or multi-user, inside of a web browser.
Mm-hmm. Cool. Yeah. Follow-up questions though. So like a lot of these terrain engines are kind of tuned toward, rendering the Earth and like the effect of the atmosphere on the Earth. Now, lighting and the way things look on the moon are very different, right? So did you have to do any special effort to get that right and make things look like they would look like on the moon as opposed to through an atmosphere?
Well, actually, yes, you're absolutely right that it's quite the headache. And so what we do is we first take the elevation data from LRO, then we apply the photographs, the textures, which is like, if you ever did papier-mâché figurines, you build a wireframe out of chicken wire, for example, and then you put old newspapers over it, and then you paint, right? So it's the same in 3D, but that's how far it goes, which anybody in 3D modeler can do. Our special sauce comes in the tuning of the lighting model and the shaders. Now I'm talking technical language for real-time interactive 3D graphics. So I mentioned earlier that the light of the sun is extremely harsh on the moon because it's not softened as it is on Earth by an atmosphere. And so you have extreme contrasts and extreme brightness and extreme darks, etc. And so it's a whole black art to approximate that. Remember what I said about generative adversarial networks.
Yep.
So we think we already got pretty nice and close to getting the feel for the look and feel of the moon right. But we can do better still, and we intend to do so with the use of GANs, GANs.
Yep.
In a sense, virtual moon will never be finished because we'll get better data sets over time, and the technology will improve, and the graphics will improve, and we'll take advantage of all those improvements to consistently deliver at the very edge of what capabilities we have, based on limited only by the data and the capabilities of the technology.
Yeah, I got to say that's like a perfect application of GANs. That's really cool to see. Let me get to a question here from Luke. He says, maybe I missed it, but why is Malapert Mountain special to you?
All right. So I came up with, when I was with Space Frontier Foundation, I thought it was important to sort of start collecting ideas and concepts. And the best way to do that is to imagine a city, an advanced city, taking advantage of all the best technology available, and come up with a concept for that city. So one of the first things we needed to figure out is where do we want to build the city? And one of the conferences I attended, Dr. David Shrunk talked about Melapert. Melapert is near the South Pole, is on the 0 meridian latitude line. And so because it's so close to the South Pole, it's got a perfect view of the Earth. The Earth is very low on the horizon. And so Saline City is conceived as a destination resort, a vacation spot. And the reason is because at that point in time, in 2045, robotics will be so advanced that there'll be no reason for human beings to go to the moon to do any work. But human beings will still want to go to the moon, but why? Just to experience the moon. So it's the perfect location to build a resort destination for vacationing on the moon.
Awesome. And we can do it virtually without even having to go there. So even better. Cool. I think that's all the questions we have for now. So if you do want to hit one or two, oh, wait, we got one more. Luke wants to know if you'll be sharing links to where we can view these demos online. You mentioned that. I think we'll get those later, right?
Yes, I'll share them with Sharif so she can share it with the group. But I would invite you all to visit our website and give us your contact information, your email, because we have a special gift for everyone that does that. You automatically get 100 square meters of virtual moon terrain just by signing up on our website, and then you get free access to all of the demos that we have available.
Way cool. And Rob, go ahead.
As a kind of a capstone, you see the little dome in the center of the image here. That's the exterior of the Lunar Lounge that we saw in the earlier demo. So it's really something that is accessible by elevator from the Saline, the city, which is inside, subterranean, underneath the top of Malapert Mountain. And so in a future version, this will be transparent, and so we will basically be able to see that observation dome right there.
Mm-hmm.
So Saline will be again a fully rendered virtual reality city, very large for 5,000 people. Again, you can meet your friends there and go exploring and learn about the technology, all the systems that make this possible. But it's more than the visual simulation. It'll be a digital twin. We want to simulate all the technologies that will be used to build and operate Saline. And it's a way of, again, remember, we want to inspire young people, and Saline is designed to be near future, not so far off in the future that you lose the connection to it. It'll be built in 20 years from now, by the year 2045. So we want to take all those young kids excited about space and transport them to the future and let them experience what is possible to do. The only limitation on Saline is what is possible technologically. We don't care about, what's the business case, financing, politics, geopolitics. We threw away all of those concerns, and we're just concerned, what could we build if we set out in a very serious way to actually build this? What could be done based on technology alone?
Oh, I love it. Yeah. So just like the best science fiction, you're just inspiring the next generation of what could be, and maybe one will make it happen. That's awesome.
And a time travel experience, just like you can travel back to the 1969 and experience history in the making. We want to teleport you to the future and so you can experience the future.
The eagle-eyed among you will have spotted this line of little dots going from the top of Malapert Mountain to the edge of Shackleton Crater. That's not a bug. That's the result, the output of a terrain traversal calculation exercise. And basically, this is the outline of what we call Lunar Highway 1, which is a route that will take you in about 4 to 5 hours from the top of Malapert Mountain to Shackleton Crater over lunar terrain that is not steeper than a certain angle, which is negotiable by something like the lunar rover from the Apollo missions. So it's not a bug, it's a feature.
Yeah. That reminds me of something else I want to mention too. Like some of the mountains on the moon are really big, like bigger than we think. And, kind of being there virtually probably drives that home pretty viscerally, I would think.
Absolutely.
Yeah. We have one more question from Rob Fleming, and it's a great one to wrap up on. He says, you mentioned volunteers. What type of volunteers or specialties are you looking for?
So many different opportunities to be part of the Virtual Moon team. One of the things that I do is I go to schools and I talk to kids about this, about how important it is we become a spacefaring civilization. We tell them that they are the generation that's going to be building that future, and we encourage them to consider careers in the STEM fields to give them the best opportunity to participate and contribute to building that future. And I bring VR headsets with me, 2 or 3 VR headsets, and every kid that is there, I usually talk to groups of 20 to 25 kids. Every kid gets to put on the headset and experience what it's like to stand on the moon and watch the Apollo 11 land and come down and land right in front of them. It blows them away. It's a life-changing experience for many of them. Again, we have lots of reaction videos that are just amazing. And so that's one way of volunteering. You become a Virtual Moon ambassador. We have people from all over the world that have found out about Virtual Moon, and they get in touch with me, and they want to be part of Virtual Moon. And so I've been able to buy a few virtual reality headsets and ship them to Tanzania and Tunisia. We're going to be shipping a couple of them to India soon. And I just interviewed a new Virtual Moon ambassador. I didn't tell you about this, Philip. Interviewed a young lady who's super excited. She wants to be the national ambassador for Ecuador. So we're going to be shipping her a headset as well. So this is something that anybody can do. If you're passionate about space, you want to share it with young people, that's something that anybody can do. We also need subject matter experts to help us design Selene. We have a conceptual design at this point. We want to really dive deep and start creating a level of detail and designing the actual systems that will be part of Selene. And then based on those designs, we'll build the digital twins for all the systems and subsystems and components and build out a complete working model of Selene.
Very cool. I did see one more question come in from John Pinto. He's asking, is there a paid version of Virtual Moon? And if so, what comes with it?
Okay, so Virtual Moon will be free. The sort of the entry level, everybody will be able to go to the moon and explore and experience the moon. But then we'll offer a lot of additional features that you can access. But one of the main things, I'll just share with you some of the business models. So one of the things we'll be doing is once Virtual Moon is completed, you'll be able to own Virtual Moon. You'll be able to purchase Virtual Moon property. It's a very reasonable price. It's 1 penny per square meter. So $1 gets you 100 square meters. And that's something you can do right now, by the way. If you go on our website and donate $10, you get 1,000 square meters of lunar property. So once Virtual Moon is completed, it's finished, you'll be able to explore it and find a spot that you really love. It's a fantastic view. You'll love that view. And you can, if it's available, you can claim it as your property.
Maybe I could add to that, which is that what Manny described is the consumer-facing version of Virtual Moon. We will also have a version that is for professional space people, professionals. So a space industry-facing version where you can use the Virtual Moon as a mission training tool, but also to help with mission troubleshooting. Like imagine if they had something like this for the Apollo 13 mission, that you can recreate in virtual reality tons of scenarios. They had to do it in physical simulators and they succeeded. But the idea is that you would have something here where you can do mission planning. You can also calculate how much solar energy your photovoltaic cells on your little unmanned buggy or rover will catch if you choose a certain route on the south pole of the moon instead of another route. So you can measure how much you can do terrain traversal studies to pick the best route for optimizing for sun exposure, etc.
Awesome. Yeah, the simulation and training applications are staring you in the face, so that's awesome to see. All right, we're just about out of time here. Is there anything you want to wrap up on? Any last thoughts?
Again, Virtual Moon is open for collaboration. If you're interested in what we're doing, we would encourage to get in touch with us. Any kind of expertise, if you life support systems or power systems experience, or architectural experience. If you want to get involved into the design of Selene, that's one thing. If you want to get involved in the outreach program and become a Virtual Moon ambassador, and help us get the message out. Our goal with the Virtual Moon Ambassador program is to make sure that any kid anywhere in the world, no matter how remote a place they live in, there will be somebody visiting them and giving them the opportunity to have this experience. So we need lots of people for that effort, and all are welcome.
All right. Awesome. Thank you so much, Phillipe and Manny. Thank you for taking the time out of your day-to-day to spend with us, and best wishes on Virtual Moon. This is awesome stuff. So thank you so much.
Thank you for having us at Astra.
Yes, at Astra. All right. You're welcome to hang out if you want to, or get back to whatever you have to do. Go get some dinner, whatever time it is there. But thanks again for having us, and thanks to Sharifa for introducing us. And
Thank you very much.
Yes, thank you. And with that, folks, thank you for hanging out. We still have a quorum for our elections, and that's going to be up next here. John Pinto, do you want to let me put up the slate here, and I'll let you speak to it, assuming I can figure out how to share my screen again. Share. Screen 2. There we go. Bam. All right, John, over to you.
All right. Very good. Thanks, Frank. So these are the folks who raised their hands and said, yep, I will work on the board. And so we just need everybody's vote, the up or down, to accept this slate of new officers. So we have Wes Clem, who is running for president. Wes was one of our board members at large. And he's stepping up to take Frank's place, who has done a wonderful job the last few years, and we're going to miss him very much. Sharife is going to stay on as vice president. I am moving from my board member at large role to take over treasurer. Thank you, John Frank, for your years of service. Debbie Vaughn is going to remain as our secretary. Denise Woody, who used to be our secretary, is now going to be one of the board members at large. And John Frank, who was our treasurer, will be the other board member at large. So no one else raised their hand and said they wanted to run for any of these. So this is the current slate of electors.
All right, I'm going to kick off a poll here, and hopefully you should be seeing that right now. Just go ahead and click yes or no on each individual position there, and we'll watch the votes come in, hopefully. And thank you so much to everybody on the board who stepped up to larger roles or new roles. Like that's what's supposed to happen. You know, people kind of rotate and learn the ropes of the entire organization. And I'm very excited about what this new board of directors will be doing in the coming years. It's a really solid team.
Me too.
Yeah, thank you. All right, we have almost everybody's vote in, and as you might imagine, it's unanimous so far. Well, almost unanimous, but close enough. All right, I think we have a clear majority at this point, so I'm going to call it. The slate is approved, so yay. Thank you, everyone, for being here and voting, and congratulations to the 2026 Board of Directors for CFAS. Yay, everything passes. Let the record show the slate was approved. And
Hey,
thank you
Frank,
everyone for showing up.
I don't know if everybody really knows what your story is because they're all asking me, hey, what happened to Frank?
Oh, really? Yeah, I'm moving to Los Angeles, folks. So, yeah, I got to hand over the reins. I only had 1 year left before I hit the term limit anyway, but that's why. Yeah, we're shipping out, literally shipping out. We're going to be taking a cruise out to LA through the Panama Canal. So that's our mode of transportation. Hope to get involved out there. The Planetary Society is out in that neck of the woods, and there's also some cool astronomy clubs out there. So hope to participate out there as well. You are, of course, in good hands with Wes. He's a great guy, and he's got some great ideas and some great energy for this club as well. But yeah, I'm just moving. That's all it is.
And I'll interject that because I'm in charge of programming, we will definitely be having you back as a speaker at some point. So just throwing that out there.
Oh wow, okay, yeah, we can do that. Cool, thank you. But yeah, I'm gonna miss y'all. It's been an honor serving for this organization and watching it grow, and it's been quite rewarding. And it will be
Watching it grow.
yes. Oh my gosh.
Really?
Oh yeah, we only had like 100 people when I started, and we're up to like 250 something now. So
Wow.
yeah, we are a growing organization, one of the biggest ones around actually at this point. And with that, let me move on. So thank you everyone again. Let's move on to club news. Lots happening. First of all, we need some help on the outreach committee. So if you have been involved in outreach, getting out there to school groups and community groups and letting them look through the telescopes, we could use a little bit of assistance there. Douglas Woods has asked for some assistance on managing all those events. If you are able to help him out, please contact him at outreach@cfas.org or contact Wes now at president@cfas.org to learn more about that opportunity. We really need an extra set of hands there. It's a lot of work and it's just too much for one guy, folks. So if you can step up, it's a very rewarding position. You get to go out there to the community, inspire kids like every week. Nothing is better. So do please consider that opportunity if you're able to. We are also seeking a new Lunar telescope chair. Christopher Hunt's job is kind of getting in the way, I'm afraid, and we do need someone to take his place as well. Of course, he's willing and able to train you up and spin you up on the ropes there. Contact loaners@cfas.org if you're interested in that opportunity. If you like to geek out on telescope gear, that is the perfect role for you. And we do have some more Geneva nights coming up, weather permitting, of course. Weather's been improving lately. It's actually pretty clear tonight, and then this weekend's looking glorious. The next organized night at our Geneva Dark Sky Night is going to be October 17th and 18th. Stay tuned for which or both of those days will actually be open. Also, October 24th is reserved, as well as November 14th and 15th. Again, this is all subject to weather and subject to availability of staff to open the site. And keep an eye on groups.io for announcements on what will be open when. Quick update on the holiday party. We are kind of, we're this close, folks, to actually signing something there and making this all set in stone. So as of now, the information I'm giving you is tentative, but we're like 95% sure how it's going to go. One thing I do know is that it's going to be on December 20th. That's a Saturday, if you can join us then. And it will be a catered event with a live speaker to be determined and the usual giveaways and fun and camaraderie that you've grown accustomed to at our holiday events. And as I've foreshadowed throughout the year, things are getting expensive, folks. We can't cover the cost of this just through your membership dues alone anymore. That $40 or $50 you paid for the year, there's just not enough left over to give you a full catered meal as part of that. So we are going to ask for a small contribution of $20 per person, probably, maybe even less, depending on what we can do for the pricing there. But do keep in mind that we are heavily subsidizing that cost. The actual cost is more than double of that. So if you can join us and you got an extra $20, please do come on out. We're not making a profit off of it. This is just covering the cost of the event. And we would love to see you out there. Current thinking is that this will actually be a lunchtime event this time as opposed to a dinner time event. And it probably will not be at the planetarium. We're looking at an exciting new venue out with a nice little view in Seminole County. But I don't want to give away the name just yet because it's not quite a done deal. But stay tuned for more information on that very shortly. The other cool thing is that because we're going to be doing this during the day, we can actually head out to Geneva after the event. So we do have the Geneva site reserved as well on December 20th. So we could go out and get some nice food and some nice camaraderie and some nice fun stuff and giveaways and all that good stuff. And then when you're done, hop in the car, head over to Geneva with your telescope, and do some observing as well. It sounds like kind of the perfect astronomy day to me, and night. Again, stay tuned for more details, and we will be looking for RSVPs and ticket sales soon. So just hang out for more news on that front. It's very exciting. It's going to be a different kind of party this year, and I think it's going to be awesome. I wish I were here for it. Also, in education news, John Sasson, our education chair, has been quite active. There is a serial processing workshop currently slated for November 4th. You'll find that in your calendar on cfas.groups.io. And we do still need mentors. John is spinning up that mentorship program still. And as you might imagine, we have more mentees than mentors. So if you are willing to share your experience in whatever you're an expert at, be it observing or image processing or setting up a telescope, whatever it might be, please do let them know. You can join the mentorship subgroup at cfas.groups.io/g/mentorship to get more involved with that if you are so inclined. Also, Emily, our new social media chair, is active as well. If you have any photos you want to share on Instagram and Facebook and all that good stuff, do send them her way to social@cfas.org. And if you have any news that you want to share with the public, that can also go her way as well. So yeah, just let social@cfas.org. Shoot her a note if you have anything that you think is worthy of sharing with the outside world and getting people excited about astronomy and maybe excited about CFAS as well. Upcoming astronomical events. The big news right now is comets, comets, comets. So A6 Lemon is kind of stealing the show right now. This is not an image of A6 Lemon because I don't have one yet, but we do have one coming up later in the showcase. But yeah, A6 Lemon is currently visible in the early morning sky here, and it's putting on quite a show. The photos I've seen of it are pretty cool. It has a very active and dynamic tail, which is kind of cool to see. Also, R2 Swan is out there as well somewhere. And I'm sure a lot of you have heard about the interstellar comet 3I Atlas. That's been all the news and hype and conspiracy theories lately. Unfortunately, it's not really going to be getting terribly close to us, so it's not going to be too interesting to look at from here for sure. Currently, it's actually heading behind the sun. You might have heard that it just went past Mars not too long ago. It should be reappearing again in December, where hopefully we'll get another good look at it and see what it's really made of. And my gosh, I got to stop looking at the internet. There are so many crazy conspiracy theories about this thing. Of course, there's people that say it says it's an interstellar alien spacecraft. I mean, I can't prove that it isn't, but so far the evidence doesn't really suggest that. The thing that really cooks me is people saying that there's some sort of a conspiracy because NASA hasn't said anything about it lately. The reason NASA hasn't said anything about it lately is because there's a government shutdown, people, and that includes NASA. There's no one there to say anything. So kind of unfortunate that we're missing this opportunity to study it more deeply. Anywho, some other cool things on a more positive note. On October 13th, the moon and Jupiter will be within 4 degrees of each other. So that'll be kind of a cool thing to see in the night sky. And on the 19th, it gets even cooler. Within 4 degrees, we'll have Venus, Mars, and Mercury all within 2 to 4 degrees of each other. Look up after sunset to see that happen. It should be quite a nice little collection of astronomical objects. And then on the 23rd, Moon, Mars, and Mercury meet up as well. Saturn is still near opposition as well, so that's still putting on a good show. We're just a month past opposition right now, so if you are able to take a look at Saturn, that's always a crowd pleaser through the telescope if you want to show that off. So Saturn is still a great thing to look at. And with that, we'll transition to our astrophotography and sketching showcase featuring our members' latest works. And I'm going to start it off with John Pinto. Speaking of comets, talk us through this, John.
Yes. So actually, I was going to add one more thing to that astronomical calendar. I believe it's tomorrow night. The moon is going to be moving through the Pleiades, which should be kind of cool if you can see anything, because the moon's going to be so bright, it might wash it all out. But hey, give it a try.
Cool.
So this Comet Lemon C2025A6. This was taken at Starfront, our remote observatory. And as Frank said, it is really bright. So, 7 minutes to capture this. It's just amazing. There are people who have even better pictures of this, I've seen on the web, but our little, S50 C star at Starfront, I think it did a pretty good job of capturing the comet and the tail. And you could see it's got probably like 2 divisions, shall we call it, of the tail, the really bright one that you see, and there's one a little bit off to the right. I'm not sure exactly where it is in the solar system right now. Frank, have you heard anything? Like, is it between Mars and Jupiter, or for being so
Physically,
bright?
yeah,
It's
it can't be that far, but yeah, I don't know.
exactly,
Yeah.
exactly.
And we also got, speaking of the moon,
Speaking of the moon, this was last night. Frank alerted us that it was going to be a very clear night last night, so I was out with my C Star S50 and did a whole bunch of other things. But to me, this was the most dramatic. image, basically 1 day past full. So over in the right side, you're starting to see the shadows come in as the moon starts waning a little bit, and it just as I think you've said, Frank, you can never stop just being amazed at looking at the moon.
Yeah, it's a whole other world, right above our heads, and we take it for granted
And
sometimes.
this was no processing. I didn't do
Mhm.
any processing. This was just straight out of the sea star. So that kudos to the sea star.
Yeah, that's great contrast and great resolution. That's really cool. Thank you, John.
No, thank
Up
you.
next, we got Raymond Gregory. If you're here, go ahead and feel free to unmute yourself. And you got
Yes.
some really cool solar images. Talk us through this.
Sure thing. This took with my Lunt 152. I was back on the 20th or 28th of August. I submitted a couple of these, but the seeing was not very good on that particular day. Fair, but I was able to get a decent image, I guess, of active region 4191, a number of different, large cluster of sunspots. And what's most, I think, compelling about the image, apart from the prominences and the sun and the magnetic field lines in the faculae of the bright white spots.
Mhm.
They are essentially the extensions of the magnetic field going through the chromosphere and penetrating into at least the bottom of the photosphere. But it's an image that I think amplifies those magnetic field lines and the contortions of those magnetic field lines in what was a AR 4191, a very impressive sunspot cluster. I use, as I said, the Lunt 152, the 3400 blocking filter, which is designed for imaging. I used a Mars, Player One Mars camera, and a bit of software. I use Fire, or rather, on this actually, I guess I used did I, I think I used oh gosh, I'm not remembering exactly what I used on.
I've got your notes here.
Oh, I'm sorry. Sure, I used SharpCap on this. I don't
Yep.
always use SharpCap, but I did here. I remember that, and AstroStacker 4 and IMPPG and Photoshop. Essentially, the images are taken in black and white. There's greater resolution in black and white photography because in a color chip, of course, with red, blue, and green, you're getting each color is taking in 1/3 of the photons. And so it takes that much longer to develop a color image with that much lower resolution. Your black and white is higher, colorized at the back end. This is still a combination of 2,000 frames, video frames.
Oh,
Well,
crazy.
in auto stacking, yeah, which
Yeah.
takes a few minutes. Here,
Yeah.
this is was taken. This is active region 4190 of Carrington rotation 2301. Carrington rotations count the rotations of the sun going back into 1883 to the present. One rotation of the sun is a little over 27 days. This shows a number of prominences, including some coronal rain. Coronal rain would be the plasma that separated, appears to have separated from the chromosphere and the photosphere is floating out in space, but falling back onto the solar surface, the chromosphere, and the magnetic field lines, a very powerful magnetic field in the sun. Also, towards just above about 3 o'clock is a large filament, and that's essentially a different angle, the perspective of a prominence with the sun in the background, the surface of the sun as opposed to space. And so these are all plasma ejections, if you will, because the sun is a very happening, boiling kind of place, as this image, I think, accentuates with the filaments and the granules and convection cells. But the filament in particular and the number of prominences covering pretty much the entire arc. I think that.
Yeah, that's a great shot.
Thank you. Future project. This also was about 2,000 frames. Similar.
Yeah, capturing that detail on the every aspect of the solar surface there and the prominences in one image is challenging. I appreciate that. So
it's tough. I can tell you, working in hydrogen alpha, which is very narrow, about 640 nanometers, is very difficult. The slight motion of the telescope changes the image from what is up there. Also, or focusing the etalon, adjusting the etalon will change. That is basically two surfaces of glass that are tuned to the hydrogen alpha band, and it's very sensitive. I know there are other solar imagers in this group, and so they know what it's like, but it can be very, very challenging. I was able to capture most of it. I did not, in this case, use the flat field filter, which I usually use, which gives me a flatter and more even distribution within the image. But it still worked out pretty well. I think the future project will be a mosaic. The 152 obviously doesn't come close to, it can't capture, it's much higher resolution than the entire solar disk. There seems to be a preference for solar disk images in Sky and Telescope magazine, though, for some reason, which I find somewhat annoying. So I haven't landed an editor's choice yet for these in Sky and Telescope. I have in Deep Sky. I also shoot with the C14. And in Planetary, I have with Planetary, but not solar, which is frustrating. If anyone has any ideas on this, they'll accept my images, but I haven't gotten an editor's choice. With regard to this group, if I may, you pointed out that this is a growing club, and I got to say, I'm also a member of the Southwest Florida Astronomical Society. It's half the size of this group. So you should be proud of what you've accomplished here. There's no question. It's substantive. It's significant. You have a robust speaker schedule. It's very impressive and professionally handled. Southwest Florida Astronomical Society is also handled well, don't get me wrong, but it's a much smaller group of people and more modest in its presentations comparatively.
Wow, that's great to hear. Thank you so much. And thank you for sharing these images. It sparks the imagination too. I mean, just like there's a whole world there with the moon hanging over our heads, there's a star in our sky, people, and we can study it. It's right there. Love it. And by the way, we have a couple of Sky and Telescope editors in the group too. So that might.
I've noticed that. That's one reason I joined.
Just saying. All right, Bill Castro. I don't see Bill Castro in the participant list. If you're hiding under a different name, Bill, please speak up. If not, I will present this on your behalf. Chirp, chirp. All right, here we go. So Bill is our resident sketching expert, and he's presented us with two sketches of the transit of Titan on Saturn, as viewed on July 18th and September 20th. And at the time, the rings were more on edge during the September 20th transit. This allowed for more detail to be viewed on the planet without the glare of the rings in the way, and it was surprising to him that a slight flattening of the rings made such a difference. During this year's equinox on Saturn, the northern hemisphere is transitioning from summer to autumn, illustrating the changing seasons. It's still warmer in the northern hemisphere, making it look brighter than the southern hemisphere. And his September 20th sketch was featured on the Astronomical League's Facebook page, and it gave the club some good press as well. So great job as always, Bill. Always love seeing this. And this was a very special event, by the way. These Titan transits don't happen very often. Obviously, with the moons being in the same plane as the rings, you only see this when the rings are kind of edge on, and that doesn't happen often either. So great job capturing that during what was a pretty cloudy time of the year for us as well. So that took some perseverance. Mark Femininio, I don't know if you're here. I don't think you. Oh, cool. Yeah. Yeah, what do we got here? Speaking of Saturn. Yep.
This was the September 20th version. I did get some of the other ones, but I didn't put them up. But yeah, Bill did a great job illustrating it. So you could see a little orange tint to Titan there with the methane atmosphere. But this was with a 8-inch homemade Newtonian. and a ASI 224 MC camera. So, pretty cheap camera, cheap optics, but and just processed with auto stacker and Registax. So nothing fancy.
Wow. I mean, for an 8-inch scope, that's actually kind of awesome, which I think you know. I mean, if that's a homemade telescope, well done. My gosh.
Thank you.
Yeah. And capturing color on Titan is also pretty impressive too. Capturing that right into processing might not have been easy. So kudos.
Yeah, and I'm not really good with this. I'm not much of an astrophotographer. I'm far more visual. But so there's probably ways to enhance both of them separately and then bring them together, but I don't know how to do it. So
it worked. I mean, just getting the moon and Saturn like to show up at the same time is hard
Right.
enough. Yeah, very well. Well, thank you so much.
But on my other pictures, it's kind of neat because it's obvious how much brighter the rings were on the 20th because it was within a day of opposition.
Right.
And the one, and actually far more noticeable. Actually, this is wrong. I'm wrong on this. This is the other one. This was the 5th.
Oh, okay.
Yeah, because or the 4th. I'm sorry, it was September 4th.
Yeah, that's what it says in the notes. Yeah.
Yeah, because the 20th. I had a better one on the 20th. That was stupid. Yeah, the one on the 20th, the shadow and the moon were just about right on top of each other.
Cool.
So you could tell that change in angle of our, the Earth in the orbit just in those 15, 16 days. So it's pretty wild. Awesome. But we're done with this for 15 years. So.
I know it. My gosh. Time will fly, though. Yeah. Before you know it, we'll be doing this again. All right. Thanks so much, Mark. Jeffrey Merrick, are you here? I hope so.
Yes,
you
here.
Are. All right.
Here
Talk us through it. My favorite group of galaxies.
I know. I've seen so many pictures of these, but images of the Stephens Quartet, and they were captured in November of last year. Sometimes I go back and I reprocess them and, change a few things when I reprocess and end up making it better. So, the arrows indicate the galaxies that are at a distance of 210 to 340 million light years distance. And that other one, the bluish one, is only at like 39 million light years. So that's a relatively local galaxy. And post-processing was done using PixInsight and Photoshop, the two principal pieces of software I use in all my processing. So
I love it when we say 39 million light years isn't that far. I mean, and cosmologically speaking, it isn't when it comes to galaxies, but my gosh, that's a long way.
Yeah, it's a part of the OP catalog. So the distant ones are interacting galaxies. So
yeah, I love that. Love that group. And the bubble, my favorite nebula.
Okay, there's a story behind this one. I've been using my Mac Newt 190 astrograph, which is a telescope designed for astrophotography, for about 5 years, and I would drag it out in my backyard and capture deep sky objects. The mountain tripod weighs 65 pounds, and it got too heavy for me, so I figured that I'd go out and invest in a Wave 150i mount. It said it could handle the weight. So I went ahead and I bought that through, what is it? Through Skywatcher. And then I got it and I tried to upgrade the firmware and that failed me. And then I end up, breaking the board. So I had to send it back and they put in a new board to my Wave 150i. And so then I got it back, I took it out, and I broke the focus assembly, and it was way out of collimation. So I had to go out and purchase a new focus assembly via Feather, was it Feather Focus? So yeah, feather touch, and so I had to replace the focus assembly. And finally, I got everything working 4 months later. And so my first image was this bubble nebula, which is at magnitude of about 10, in the constellation Cassiopeia. Um, and this particular photo image, I stacked 38 images, each with 2 minutes, resulting in a total exposure time of 1 hour and 16 minutes. And the post-processing was done with PixInsight and Photoshop. One more thing, when you take these nebula pictures, a lot of times they're very small, and using the Mac Nude, I'm able to actually bring in those small, faint objects pretty nicely. So that's why I enjoy the Mac Nude. But it's not good for these wide field shots where you have large objects and you're trying to, or large nebula, which you're trying to capture. I can't do well with that because it's, I mean, I don't have that wide a field. So
Yeah. Yeah, I'm a fellow owner of a MacNewt 190, and it's a really good balance, I think, in terms of its field of view and light gathering ability. So
yeah.
I love that scope. I'm gonna miss it. I
Mhm.
did just donate mine to the club, by the way. So if anyone wants to play around with one, that is now in our Lunar Telescope collection.
That's just the optical tube assembly that you have, or you also have the mountain tripod?
I donated the whole 9 yards. Yeah, so it's the Mighty Mount, the Paramount tripod, and also a motorized moonlight focuser as well.
And so the mountain tripod weighs about 65 pounds.
Yeah, the Mighty's. That sounds about right. Yeah, it's not like
Yeah,
it's
I,
supposed to be
I,
their
I mean,
portable one, but
I can't lift that anymore. I mean,
yeah,
yeah, mine is much more portable. It weighs like, 30, less than 30 pounds, and I can take it anywhere. So,
yeah, that's awesome. Cool. Yeah, that's amazing how technology has changed. Those wave mounts can they pack a punch. So that's really cool to see. Well, thank you. That's some awesome imagery, and seriously, two of my favorite targets there too. So thanks for sharing that. And I'm going to close it off with Pete Lefevre with some nuggets from our remote observatory in Texas. Pete, are you here?
Yep, I'm here.
Cool.
So, I guess our Wes Clem is now our current president, correct?
Yes.
Yeah.
Congratulations,
So,
Wes.
so for our remote observatory in Texas, the C-Star S50 that John was talking about, Wes built an archive. So every night, I mean, all the images from the C-Star get swept into this archive, and some of the more iconic images get imaged by more than one club member who has a night with the telescope. So every month I kind of peruse the archive to look for what objects have a fairly high number of subframes. So the two I picked for this month are, the M51, the Whirlpool Galaxy, and M13, the Hercules cluster. And so, I mean, this is showing the amount of integration for each of those objects. Now, keep in mind, this is Alt-Az mount is the mode that the C-Star is running in. And it's all 10-second subframes. So, I mean, that's kind of and Frank, you sent out that link for the PixInsight tutorials that are really focused on stacking C-Star images. So I basically just took, directly from that set of steps, it's using that stacking script, fast batch preprocessing with 1x drizzle. I still don't quite understand the explanation of why you want to do that, but I did do a comparison between using the weighted batch preprocessing and the fast batch preprocessing with those different settings, and it does make a difference. So I've got to do more research to understand why. I'm sure there's people on the club that know the reason why, but it's basically following that simple script with the exception of M13. I had to use GHS for stretching because otherwise, that core, you just can't really resolve anything but other than that, it's following those basic steps. It's the I did use blur exterminator and noise exterminator in there, but I mean, it's pretty amazing with the just the dark skies and just the little telescope. I mean, you get enough subframes, the images really come alive. So, and I know I found we have almost 7 hours of integration time on the Iris Nebula, and so I stacked that and looked at what came out of that. It's pretty stunning at just the level of detail that I just don't understand how you can get 7 hours of 10-second frames and something comes out of that. But it seemed like there's got to be some limit to where it stops looking better. But anyway, I mean, it's pretty, I know what Wes called it, the gateway drug to astrophotography, the C-Star.
So I think it's more than a gateway. This is the real thing.
Yeah. Yeah. So, I mean, that's pretty interesting just to see and the thing is, these images are coming out based on all these different club members creating a plan, deciding what they're gonna image. And, this is kind of like a group effort kind of thing. But anyway, it's pretty interesting to see what's coming out of that facility out there in Texas.
Yeah, it's just so cool. Honest to God, like I would not have guessed that these are C-Star images if you were to show them to me. These look just as good as like a 20-hour long exposure I would have taken with my 190 Mac Newt from here. So those dark skies make a huge difference. And I love the idea of like accumulating, all that data from all of our users and combining it together to make images like this. John Pinto, you got a hand up?
To mention, anybody can do this, right? Just go to the archive site. We have the link up in group site, I believe, and you can pull down all these subs from all the different people who have been using the C-Star and will continue to use it. And you can post-process it and show it to us next month. So happy post-processing. You don't even have to go out and image yourself. You can take all of these subs that people have been gathering and do your thing with them.
Yep. If processing is your thing, then we got data for you, and go and practice. And you can make unique images that no one's seen before. Love it. All right, thank you so much. And I think we're done, folks. Yeah, so I'm going to stop sharing, and we're going to wrap things up here. And that's a wrap for me. Congratulations again to the new board of directors, and congratulations to Wes Clem for taking the helm of the president role. Thank you so much for stepping up there, and for everyone else who's switching roles around. Got kind of some musical chairs going on there in the board, but it's a solid team, folks. So I'm excited to see what happens with this organization in the future. Thank you, everyone, and thank you for making CFAS awesome to all of you members as well. And I will leave you with wishing you clear skies and keep looking up. See you around, everyone. Good night.